Hello everyone, this is Engineer Abid Hussain. The purpose of this video is to demonstrate my final year project, an IoT-based smart pillbox. Under the supervision of Dr. Suresh Kumar, let's dive into the essence of my presentation, starting with introduction. Then next is literature review, aim and objectives, project flow, methodology, area of applications, achievements, conclusion, references. So introduction, what is IoT? IoT consists of an embedded technology. It involves linking everyday object to internet. These objects are equipped with sensor, software, and connectivity. Data interaction, they are capable of gathering and exchanging data over internet. Information exchange, the primary objective is to collect and share utilized information. Internet of Things, which also consists of automation, monitoring, and analysis or real world application. IoT enables automation and remote control of various processes and tasks. Collected data can be monitored and analyzed for insight and improvements. IoT finds application in various fields from smart homes to industrial automation. The second part of this introduction is IoT-based smart medication box features. Remote monitoring using an IoT-based smart pill box can be connected to internet, allowing caregivers, doctors, or family members to remotely monitor the medication intake of patient. Customization: an IoT box can be customized with the help of an Android app to meet the specific need of patient, as adjusting dosage according to patient's changing need. Introduction also consists of the second part of introduction, which also include increased safety. An IoT pill box can help reduce medication errors by ensuring the patients that take medication at right time and right dosage. Easy of use. An IoT pillbox is user friendly and easy to use. It can be controlled using a smartphone app, making it easy for older adults. Following are the previous work that has been done in past. The first one is the first medication box. Its flow chart is node, which consists of node MCU, LEDs, cloud, Android app, reset button, OLED display, buzzers. The second one is which consists of a ESP32 module, LCD, and servo motors. This box also have the feature of configuration and generating emails, real-time clock, and the second one is which consists of LEDs, buzzers, and LCD display, Wi-Fi module, and also it consists of a which we can say servo motors, which is used to display the medicine from the box. Literature review, comparative analysis of literature review, which is you can say technology-based comparison. The first one box, the previous that has been made in past years, which is an IoT based smart pill expert system. Its features are display, alarm and light indication, push buttons and buzzers, face recognition system, and its limitations are it cannot generate modification caregiver. Mobile app also its limitation, remote control which we cannot control remotely. The second one is a smart pill box with remind and consumption using IoT. Its features are finger detection is used to identify the patient. LEDs and alarms dispense of medicine from the pill box, and its limitation are medical non-adherence without Android F. It's costly. The third one, an IoT-based smart medicine box for medication. Its features are programmable alarm system, automatic opening and closing system, automatic report and email generation. Its limitation are limited security in terms of identifying user, no security protocols in place. No mobile app, it cannot generate notifications. Here is the fourth one that I have designed an IoT-based smart pillbox. Its features are real-time updates, medication setting for different patients, fastest sensing capability is also its feature, automatic report and email generation, Android app using MIT App Inventor, medicine time reminder, complete integrated and functional box. Charging capabilities is also one of the feature of my box. Its limitation are face recognition of patient, automatic email dispense of medicine from a patient. Caregiver will took instead of that patient or caregiver will took medicine from the box. Finger detection is also its limitation. Here are the aims and objectives of my smart medication box. To design an IoT-based smart pill box is to monitor whether the patient taking medicine on time and regularly on the instruction of the doctor. Following are the main objectives of smart pill box. Number one, monitoring the schedule dispensing. Monitoring the dispense of pill box from the schedule time, and the second one is medication guidance, providing guidance to patient for taking their prescribed medicines correctly as per the instruction of doctor. Real-time medication pattern tracking, monitoring and recording the real-time pattern of medicine intake to identify adherence and duration of a patient. Custom dosage setting, allowing customization of dosage schedules of different patients at various times as per required. Cloud-based data configuration and notification, configuring data and generating text notification through cloud connectivity, facilitating communication between caregivers and doctors. So here is the project flow of my hardware, which is started with the set the schedule time, then update the time. It will update time as per the real time, which will pick from the Google. If the current time is equal to schedule time, if yes, it means if current time equal to, it will again check if current time equal to morning time, then it will move to compartment 1, where compartment 1 tablets 1, compartment 2 tablets 1, and compartment 3 tablets 2. If no, then it will check next condition. If current time equal to afternoon time, then it will move this compartment. In the same way, if again it's not true, then it will move. If current time equal to evening time, then it will move this compartment. And now let's move to the flowchart of a software, or we can say Android app. Here is the, let's start, and initially it will connect with the AI companion. Then it will check the first condition. If screen 1 equal to home screen, if yes, then it will move to home screen. Here it will show the real-time update. Supposedly it's 11 p.m. And you have to take 2 tablets and from box 1. So here are the 3 main buttons, especially morning, afternoon, evening. If again it will check if click equal to morning, then it will move to the morning dosage setting compartment. If current time equal, if click is equal to afternoon, then it will move to the afternoon compartment. Here it will check the dosage setting, and if you click here evening, then it will move to again evening compartment. And here you can set the dosage as per the instruction and requirement of the doctor. Hardware interface. So methodology, hardware interface, the smart medication box consists of following components: node MCU, OLED display, limit switch touch sensor, 4 LEDs that will be used in different compartment, and lipo battery which is used to charge the pill box. The following configuration are shown here. Here is the battery, ESP30 module, touch sensor, LCD, limit switch, and LEDs, which is the VCC pin of ESP, VCC pin of battery, which is connected to VCC pin of ESP32, and VCC pin of touch sensor, and so on. Here you can take help to connect the pin of ESP32 module with different components of the box. Methodology and write F is also the part of to designing this box. Here is the Android F coding block. It's user-friendly platform. Methodology and write F coding block, a user-friendly platform for creating mobile apps without coding experience. Drag and drop components to build a functionality in which we do not need to do traditional coding. So that's why we need to drag and drops, which we can use, which we can build app. Methodology also consists of and write app design block, in which here we can say visual user interface design. In designer block, user can add components like buttons, labels, image, and more onto the app screen. Event handling, a user can interact with the app using event handlers such as button click, screen swap. Here we can see this is the morning research setting. Here's the box one. If you want to take medicine, then click here. If you do not take medicine, then click here. In the same way, box two in the morning, if you want to take medicine, then you have to click here. If you do not need to take medicine, then click don't take. In the same way, here you can enter your IP address in order to connect this app to cloud and then ESP32 module. Home screen, if you click home screen, then you will land to home screen. If you click afternoon, you will land on afternoon screen. Here you can set your medicine or the setting is in afternoon. If you click evening, you will land into the evening dosage setting, and you can set your screen as per your requirement. As in the evening, if you want to take medicines, then you have to click on the box one, take two in the same way. Here is the methodology in Write App design block. The design block in MIT App Inverter is a graphical interface that allows user to visually design the user interface of their main screen. Real-time run review of components and properties are added or modified. The designer provide a real-time preview of how the app will appear on the mobile device. Layout arrangement. The designers support different layout arrangement like horizontal and vertical arrangement, as well as more complex layouts like grids and tables, you can say. Here you can say, here is that if you click here, you will get updates from real time. It's afternoon 11 p.m. and if you click morning, you will get the morning time real update. If you click afternoon, you will get after time updates. If you will click here evening, so then you will get the evening updates on your Android app. So the methodology also consists of the design of SolidWorks. So before designing the medication box using SolidWorks, and before to print 3D design, you have to consider following parameters: length and width. The length of my box is 180 mm and its width is 85 mm. And 4 premises, here is the premises 1, premises 2, premises 3, and premises 4. Premises 4 is which is used to put different circuitry and electronic components in order to make the box clear. Side disc, which is used to here are the side discs that we will use to pass different wires to different compartments. Complete printed box. Here you can say the box of 4 different portions which will be used to place different tablets in respective portion. In each respective portion, there will be an LED indication to guide the patients to take their respective medicines. For example, when LED1 is blink, light will light off. LED1 will light up. Then it means that you have to take medicine. You have to take medicine from their respective box. The inside of IoT medication box, here you can say this is capacitive sensor. This is a OLED display. You will can get real-time update on screen. Here box one, the LED of box one is blank, it means you have to take medicine from this box. This is the circuitry of the box inside the compartment. Methodology, here is the visual demo of my product. You can give power to the box, and you can upload the Arduino coding to the ESP32, and then your app will automatically connect to ESP32, and you can set the dosage setting according as per your requirements. Area of applications: hospital centric medication treatment, home centric medication treatment. Second inning homes, we can use our medication box in all our second inning homes. Achievement and recognition: Alhamdulillah, my project is being funded by Ignite, and the second is my project is also selected in NIC Hyderabad for the start of purpose. Conclusion: IoT-based medication box have the potential to improve patient outcomes. IoT-based medication box can reduce health costs by improving medication adherence. Technical consideration, including user experience and integration with healthcare system, are all important factors to consider when designing these boxes. Further research is needed to better understanding the long-term impact IoT medication box on patient outcomes and healthcare costs. This is my final year project poster in IoT-based smart medication box supervised by Dr. Suresh Kumar. Here is the aims and objectives of my final year project. Here is the introduction. This is the project flow. I have used Node MCU that I will use to communicate through cloud server, and I also use limit switch to open box. I also use proximity sensor that I will use to touch, and it will indicate us to take which medicine to take. Here's the introduction. This is the problem statement and proposed solution. Here is the hardware flow. Here is the methodology that I have used in my final year project. And here is the results and discussion. This is the screen that we'll use to set the dosage setting. Here is the complete medication box that I have developed in my FIP project. Here are three compartments: compartment 1, compartment 2, compartment 3, and this compartment will be used for circuitry purpose. Here is the display, and here is the LED glow. And if a patient touch this capacitive sensor, then it will guide us to take which medicine to take. It will automatically glow the respective LED. Here is the sequence that will be available on Android app. Here, if you click here, you will get real-time updates. Here is the achievements of my final project. It is selected by National Grassroots ICT Research Initiative, NEGRI. And also my 5 project is selected in National Incubation Center, Hyderabad. Here is the conclusion of my final year project. Here is the references you can refer to get insights. These are also references. You can follow us on Facebook and YouTube. Thank you so much.